day to you, sir. I'm Midshipman Prudente Babi Jr. from Section Barrio, and this is my lecture laboratory assessment. So, according to instruction, using schematic diagram of the resistor connected in a series to construct a circuit, we will use the MB100 kit. So, for the diagram, please wait for a second. You can see this is the MB100 kit, and there's a lot of components, but based on the instruction we will use only EC transformer, rectifier, and resistor. So before to perform, we will identify the value of each resistor. So the R1 in the figure that gave to us, R1 has a value of 1000 ohms, and R2 has a value of 10,000 ohms, and R3 has a value of 4700 ohms. So this is the MB100 kit. So before to connect the resistor to series, we will first connect the AC transformer to the bridge rectifier. Here, the AC transformer and the bridge rectifier, we need to connect it. Then the AC transformer has 12 volts, and the bridge rectifier is the purpose of this bridge rectifier is to convert AC to DC, to DC. So based on the diagram, we will connect the positive side first of the bridge rectifier to the R1. Here, the positive side of bridge rectifier, and this is the R1. Connect to the R1. Then to the R1 is equivalent value of 1000 ohms, and the positive side of R1 connect to the negative side of R1 connect to the positive side of R2. Here, connect the positive the negative the positive to negative side. Then the R2 has a value of 10,000 ohms, and the positive side the negative side of R2 connect to the positive side of R3. Here, connect to the positive side of R3 to finish the circuit. The negative side of the R3 is, we will use it to connect to the bridge rectifier to finish our circuit. Here, this is the final look of our activity in electro. To understand more, I prepare another schematic diagram and the solution in the lower part of the diagram. One moment, let me show you. And this is the diagram that I draw, and under and below of them is my solution, how to solve it. And this is the transformer, and this is the bridge rectifier. Transformer and the bridge rectifier. This is the transformer, and this is the bridge rectifier. and this is the R1 1000 ohms, and this is the R2 the 10,000 ohms, and this is the R3 the 4700 ohms. Before that, we in our session I explain how it works. We use ohms law here. Here is the ohms law, but we use it now. And if you can see, this is my solution, the lower part of my diagram, and that is my solution. So the formula that I use is ohms law, so we use that later. But the total resistance, just simplify add simplifying add the all value of the resistor. So the 1000 plus 10,000 ohms plus 4,700 ohms, then so it is a total of 15,700 ohms. So for the total current is, we just divide the voltage divide the voltage, this, and the total of 15,700 ohms. So the total current will be here 0.000076 amperes. So for the voltage, so the voltage drop of its resistor, so far the R1, the voltage drop will be the total current plus R1. The total current plus R1, it equals for 0 so 0.0076 ampere times 1000 R, it will be 0.76 volt. And for the R2, the voltage drop is change here the 1000 to 10,000, so it will become 7.6 volt. And to the R3 has, just simplify times, copy that, and then change it to the R3 value of which is 4700 ohms and equivalent of 3.57 volt. So to check the total answer, we just simplify, add all the voltage drop 0.76 plus volts plus 7.6 volt plus 3.57 volt is equals to 11.93 volts. Simplify, round off because of the number here, 12 volts. And that's it, my explanation about how I solve and draw the schematic diagram. Good day and have a nice day. Thank you.